look at chapter 16 in the dog's book. So I'm looking at page 445 right now. I know we've jumped ahead a little bit. Typical year, we might get through all of the chapters in the dog's book, but we're going to get through the ones we need to satisfy your credit at BSU. So 16 today, and then next week we'll figure out where we're at. It'll be, 14, 15, or 17. I'm not sure which one. I have to decide. Okay? So we're going to be looking at changing our point of view as a way to solve a problem here today. So the first question, it's the 9 dots problem on page 445. It says, without lifting your pencil from the start to finish, draw 4 line segments through all 9 dots. The solution has nothing to do with how wide the dots are, with the idea that possibly the lines determined by them are not parallel. The points are mathematically defined. They have no width, and they determine sets of parallel lines. Okay, so we got to try to figure out how I might be able to do this. So I'm going to try to sketch this as best I can here. So that's not perfect, but that's a rough idea of what we're looking at. The real key to this problem is like they're saying here, we have to change our point of view. We're thinking we have to stay within the box, no pun intended here, but we really don't, okay? If I want to sketch this one, okay, 4 lines without moving my pen off the paper here. So we're going to go this, we're going to extend it. We're going to go through these dots and extend it. Come back to here. So there's your 4 lines. So changing my point of view in this case meant I needed to get off of the 3x3 box that I was on and extend it. And there's no rule saying you can't. So sometimes literally think outside the box to see what you can get. Okay? We're going to go through 4 examples here today, and then we'll look at another 3 tomorrow. So the second one is the human factor. Okay, it's on page 446. It says, Mayra is a human computer. She has appeared on talk shows to show off her amazing ability with numbers. One type of problem Mayra is very adept at is this. A person from the audience will give Mayra a number, and Mayra will immediately be able to tell how many 1-digit factors that number has. For example, if you were to say 50, Mayra would say 3 because 50 has 3 1-digit factors, 1, 2, and 5. Okay? One day Mayra was on a well-known talk show, and some wise guy in the audience asked Mayra to tell him how many 1-digit factors the numbers from 1 to 100 had. The answer is not 9, because Mayra had to count each factor for a particular number, then add the count of the number of factors for each of the other numbers from 1 to 100. For instance, even though the factor 5 appears in the factorization of 50, it also appears in the factorization of 45, so it has to be counted twice. Mayra quickly programmed her brain to give her the answer, and she had it in a few moments. What was her answer? Okay, now, initially we're thinking to maybe make a systematic list. Well, we would say, okay, the number 1 has 1 as a factor, and 2 has 1 and 2 as a factor, and 3 has 1 and 3, 4 is 1, 2, and 4, etc. And I can keep doing this. I could make a systematic list, and I could count up all the numbers over in this column, and I could get my answer. But there's a lot, you guys. I don't really want to do that. There's got to be an easier way. The easier way is to look at it from a different point of view. Instead of thinking of all of the numbers from 1 to 100, think of the 1-digit factors. Okay? Those are all the 1-digit factors. Well, how many times is 1 listed as a factor from the numbers 1 through 100? Well, that one's easy. There's 100 of those. 1 goes into every single number from 1 to 100. Okay? Well, 2 is a factor of all the even numbers, and from 1 to 100 there are 50 even numbers. 3 is a little trickier though, because 3 doesn't go into 100 evenly. We quickly realize 3 goes into 99, and so 99 divided by 3, there's 33 of those. 4 goes into 100 evenly, 25 times. 5 goes in there 20 times. What about 6? 6 doesn't go into 100 evenly. You know, we can find the nearest number under 100 that 6 will go into and divide by that, or we could just round down. You know, 100 divided by 6 is 16 point something, 16 and 2/3, I think. So if you divide that out, you round down, there's going to be 16 numbers that are going to work. 16 divided by 7 is 14 point something. 16 divided by 8 is 12 point something, and 16 divided by 9 is 11 point something. Well, at this point, I've got all of the times that those numbers show up as factors. Now all I have to do is add those up. And if I add all of those up, I get 281, and we're done. So again, we had to look at it from a different point of view. That was kind of the idea. Okay? The third one we're going to look at today is an average speed one. Jock left his home in Austin and drove to San Antonio. On the way there, he drove 40 miles per hour. There's a lot of traffic. On the way back, he drove 60 miles per hour. What was his average speed? Okay, well, the trouble we have here is we don't know how far it was. An average speed, we gotta keep in mind, is the total distance divided by the total time it took. And all we know is the rates, the average rates for those. The way we can think about this from a different point of view is to come up with a distance. Let's make one up, okay? So let's say the cities are 120 miles apart. Now I pick 120 because the rates were 40 miles an hour and 60 miles an hour. So on the way there, if we went at 40 miles per hour, 120 miles, that would mean we did this for 3 hours, okay? And it really doesn't matter what number of miles I pick, we're gonna be able to figure this out regardless, okay? And on the way back, we were going at 60 miles per hour. Now, if we're doing 60 miles an hour, 60 goes to 120 twice, so that would have been for 2 hours, okay? Now, the average speed, okay, the average speed isn't just halfway between 40 and 60, which is 50. Okay, it seems tempting, but that's not the case, okay? So the average speed is going to be the total distance traveled. Well, we went 120 there and 120 back, so 240 miles, divided by the total time it took. Well, we spent a total of 5 hours driving. You take 240 miles divided by 5 hours, that is 48 miles per hour. Okay, so I just want you to look at these from a little different perspective when you figure these out. Okay, good luck.